If money were no object, then I can say with full certainty that we would build our cars to our absolute dream spec. Now, unfortunately, money is usually the primary thing that holds us back from buying the car parts that we actually want for our builds. Now, there's one surefire way for us to be able to sidestep this issue, and that's by making our own custom car parts. This can be accomplished a multitude of ways, either by fabricating your own parts out of metal, fiberglass, 3D printing them, or even outsourcing them to have them CNC machined or 3D printed if you don't have your own 3D printer. Now, one tool that I can say for absolute sure will help you in this endeavor is going to be a 3D scanner. 3D scanning is one of those tools that once you use it, you'll see it's an absolutely invaluable tool. We all know how hard it can be making things that fit your particular build and the idea that you have in your head. 3D scanning is going to allow you to take the object or area that you need to design in or around into 3D space, allowing you to be able to more accurately and more confidently make your parts. Now, with this being said, 3D scanning can ultimately become very expensive if you look at the tools that you see a lot of people actually using. Some of these things can cost upwards of $10,000, if not $20,000, $30,000. But you can actually achieve usable 3D scans with a relatively low entry price, if not completely free, just using the things you already have. My name's Derek, this is FatalRPM, and in this video I'm going to show you 3 different ways at 3 different price points for you to be able to 3D scan your car to make your own parts. These 3 different price points are going to be $500 to $1,000 option, a under $100 option, and also the free option. And for me to show you the pros and cons of each different price point, we're going to be creating a intake duct for my 1986 Nissan 300ZX. Now, if you've been a part of this channel for a while, you'll be fully aware of what this 300ZX, nicknamed Miso, has had done to it. But for those of you that are new, a few years ago I pulled this engine with the intent to give it a full refresh, and it turned out that it actually needed a lot more machine work than I initially thought it may going into it. This resulted in just a bit of scope creep to the point where now Miso has a fully built bottom end waiting for a built top end with a GT70 style turbocharger bolted to the side of it. We also have this wide body kit, which, criticism aside, gives Miso even more of a presence than the Z31s already have. Now, with this being said, I want to take this body kit a step further by customizing it and even eventually creating my own kit in the future. Starting by feeding our turbocharger through an intake on the front bumper, similar to that on a Rocket Bunny kit for an S13 180SX. The plan for this is to cut this main beam here in the front, have the intake snake around, and goes straight to our turbo, getting the coldest, most uninterrupted air straight from the front of the car. This leads us to the free option of 3D scanning, which is using our phones that we already have in our pocket. To do this, all you need to do is go to the App Store and search a 3D scanning software or photogrammetry software, which will allow you to be able to take multiple pictures from different angles, stitch them together to create a relatively accurate 3D model. Now, some phones, similar to my iPhone 13 Pro Max here, will have a LiDAR scanner on the back. Some apps will be able to use this to get a more accurate and quicker 3D scan. Now, while there are many apps on the App Store that will allow you to 3D scan, the one that I'm using is called Polycam. The only reason why I'm using this one is because, well, it's the one that I'm familiar with. So starting off with it, we are going to use the photogrammetry option, which will take a myriad of different photos at different angles and compile them all into a 3D model. And basically all you want to do is make sure you have even lighting on your subject, and you want to slowly and somewhat steadily pan around, up and down around your object. The more pictures, the better with this process. That way you get as much definition as you can out of it. Now, once we're done, we're going to go ahead and hit stop, and the app's going to take some time to compile everything into a 3D object. So while we're waiting on that, let's go ahead and move over to the LiDAR process. Now, LiDAR here is pretty much more of the same. The biggest difference is it's not going to take nearly as much time to actually get the scan done. And this is because LiDAR is able to capture more information in one frame than photogrammetry is, because it's going to get that depth out of different pictures compared to LiDAR, which is just going to use the lasers. So you see, once we go ahead and start it up, we'll immediately start seeing little triangles or polygons, and that is the information that is actually capturing in its scan.
The blue areas are areas that the scan either cannot get to or it has not scanned yet. Generally, it's based off distance, but that's also a setting that is adjustable. So as you can see, I'm really focusing in here on the black hose and trying to get that gap in there just to make sure we get all the detail, because things like LiDAR and a lot of other 3D scanning applications generally have issues scanning either reflective pieces or black pieces. And that's because they generally absorb more light or reflect too much light to actually be able to get an accurate scan on it. But we're pretty much going to do the same thing. The only difference is we're not going to go back and forth over the same areas, because once you go over it once or twice, it usually gets all the information that it's going to possibly get. I'm going to focus in here on the central area and just move through the rest of the car, going up and down, up and down. Also going to try and get a little bit of the turbo in there as well, just so that I can kind of get a little bit of geometry to play around with in the CAD software. So once we feel comfortable that we've scanned every part of the car that we need, we're going to go ahead and hit the pause button down below. And pretty much the app's going to have to do the same thing it does with telemetry. The only difference here is it's going to take all the raw data and form that into a full 3D model. As you can kind of see here, it did get a lot of the wall and everything in the background. Where you see all those little green triangles is basically the perspective of the phone itself. So we need to go ahead and allow their servers to go ahead and make this into an actual usable 3D file. So while we wait for this to complete, we can go ahead and move on to the second option.
Now, if you're a gamer similar to me, you might actually recognize this second option, and that's by using an Xbox Kinect. These are game controllers that came out for both the Xbox 360 and this one, which is the one for the Xbox One. Now, there are a multitude of differences between the two. However, from what I've been able to read, the Kinect V2 is going to be your best option for scanning larger parts. I'll go ahead and link a video down below that goes more in depth on the differences between the two when it comes to 3D scanning. Now, these can be had on eBay for relatively cheap. We're talking around 15 to 30 bucks for used, as well as some new old stock at around 80 to 100 bucks. Now, with this all being said, the Kinect V2 option is a bit of a long shot nowadays. And the reason why is because the software technically is no longer supported for the Kinect V2. However, there are places online where you can still get a mirror version of this software for free. However, as it comes to downloading anything off of the internet from an untrusted source, do this at your own discretion, as obviously these softwares can have malware in them, depending on where it came from and who's supplying it. And it's for this reason that I will not be linking the software down below, because I just cannot be sure and I don't feel confident in sharing a link to the software if I don't know if it's completely safe or not. With this all being said, let me show you how to use this guy to 3D scan.
So in order to use the Kinect as a 3D scanner, we need three different things. Obviously, we need the Kinect itself. Second thing is going to be a kit to actually connect it to the computer. And the third thing is going to be the computer itself. Now, this is a relatively straight-ish forward setup. We need the computer and we need the K-Scan software on the computer in order for us to be able to 3D scan it. So I'm getting the computer set up here in order to do so. Now, with the adapter for the Kinect, it is going to need external power. And depending on if this is your first time doing it or not, we also may need power for the laptop itself. Once we have everything set up and connected, all we have to do is launch the K-Scan software. If the Kinect was set up properly, the K-Scan software should be able to detect the Kinect automatically. Honestly, if you have issues with this, it's just going to be a bunch of troubleshooting. I have absolutely no idea how to get it to work correctly. If you have any issues, I had a whole bunch of issues initially trying to get this set up myself. I, for the life of me, can't tell you how I fixed it. I just know that I did. But once we get that set up, it's the same as with photogrammetry and the LiDAR. It's better if you have it in a well-lit environment. The Kinect V2 does use time of flight, which generally uses an array of infrared LEDs to shoot a pattern onto the object that it is you are trying to scan. It reads the amount of time it takes that light to come back to the sensor, which allows it to determine the depth of whatever the item is that you are scanning, which will give us our beautifully, somewhat precise 3D scan. Now, with this K-Scan software, it's relatively straightforward to do. The only issue that I see is that it doesn't have an auto capture function exactly. You can set it to take so many pictures at a time with a delay between each picture, but there's no way to just let it go infinitely and then stop it. And that's because of the way this software works. And if you ever have any issues with any alignment or anything in the software, after you take the scan, there's no way for you to really go back and redo that part. You have to just delete those parts of the scan that weren't aligned and either use that information or go back and redo it a second time. Now, once you have all the scans, all you have to do is align them, and after they've been aligned, you may or may not have a bunch of junk and other things that are floating around in the background that you'll have to delete. Once you have all that set up, you can go through smoothing and a few other settings to help you get more of an accurate and usable 3D scan. And then you can go ahead and export that to whatever file format is needed for the CAD software that you would be using. In our case, we are using Fusion 360. So I need to export it in an OBJ file format, which I did not know at the time of doing this. So instead, I exported it as a poly file, which is not a file format that Fusion 360 can read.
And this is going to lead us to our third and final option, which are Enthusiast-grade 3D scanners. These are going to give us our most accurate scans, and also it's going to allow the process to be the most painless. Now, there's a bunch of options from companies like Creality, as well as RevoPoint and Einscan. With all that being said, I'm going to be using this, which is the RevoPoint Range 2. This 3D scanner is made to be able to scan larger objects with more detail, because a lot of the lower priced ones are really good at scanning small detail on small objects. Say, this water bottle here. However, when you blow this up about 1,000 times as the size of something like a car, a lot of that detail can be lost, as well as a lot of the tracking can be lost, because the distance of which you need to be away from that object to get a successful scan is really close. The Range 2, however, is made for you to be at further distances as well as still get an accurate 3D scan. So let's go ahead and see what the process is like getting a 3D scan using this guy.
I feel it necessary to say that this is not a paid promotion and I pay with this with my own money. That being said, RevoPoint sends you this nice case with the scanner itself in it. This guy here, which is a little battery bank for us to be able to scan it wirelessly or using a phone in that phone holder there, which will allow you to mount the scanner on top using this little adapter here, which is basically a cold shoe that will screw into the bottom of the scanner. In addition, it also comes with a extendable tripod, which you can use to be able to, well, stand it up on its own and use it with a turntable, or to hold it, and if you have bigger hands or if you want to dual wield it, or use two hands with it, you can go ahead and extend it up and use it with both hands. But with that being said, the way we're going to be doing it is directly connected to the computer using RevoPoint software on my laptop. Now, initially when setting up the device, I did have an issue with the driver, but that was a pretty easy thing to fix. All I had to do was delete the device under Device Manager and also uninstall the driver. And after I did that, it recognized it as the device it should have. Then I was able to go through with this calibration, which had me flip and rotate the scanner a couple times. It was really interesting, but super quick, super easy. Now, in total, I did do 3 scans with this scanner. 2 scans were very similar, but the first one I spent a lot of time just trying to get used to it, used to how it scans. Now, the scanner can scan 3 different ways. That is tracking geometry, tracking with geometry and trackers, and then just using global trackers, which are trackers around the object and not trackers on the object itself. So the first time around, I did just track it using the geometry, which ultimately ended up leading to a subpar experience. Now, this is only because of certain areas on the car here. So on the first go around, I did actually attempt to record my laptop screen on it. However, it just went black when I started the calibration and didn't actually record the entire thing. However, it did start recording towards the end of the first one, so you can kind of see what the end result ended up being. Ultimately, we ended up trashing that scan before we moved on to the second one, where I had more of an idea of what it was I was actually doing. Here on the second scan, it was a lot easier to know what I could and couldn't do. The reason why I was having the issues that I had before is because I was focusing in too much on the broader areas with no features on it, like the front part of the bumper and the little cross member there in the center. So on the second scan, what I ended up doing is whenever I got to those areas, I pulled the scanner out a little bit just so I was able to better track those. Ultimately, this ended up in a better quality scan. However, I did still have quite a bit of cleanup that I had to do during and after the scan because I kept having issues where it would misalign, so I would have to go back and undo those frames. However, the third scan is where I had the most success because I decided to stick trackers to the broader areas. So that flat part of the bumper, some of the tops of the pop-up headlights, as well as parts of the front of the bumper, just to use up the rest of the tracking dots that I had on the sheet. Now, when scanning the third time with all the tracking dots, it went a lot smoother. I did have a few points where it would lose tracking, which is what you can see in red. That was mainly because I didn't have enough tracking dots in certain areas, as I was kind of focusing all of them in one area, and then I realized halfway through that I was running out of dots on this sheet and should probably spread them out a little bit more. So they're a little bit more sparse in other areas, so you'll notice that it will turn red and start losing tracking. But with all that being said, it was definitely significantly easier to maintain tracking through this entire scanning process, and ultimately this was the best result. So in addition to the tracking dots, the other thing that I did do was I wrapped the coolant hose for the radiator in a little towel. Since it is a black hose, it does have a little bit more of an issue 3D scanning with this scanner, and having that shop rag on there or the shop towel on there made it scan a lot easier. And I really do like the way this model turned out. But with that being said, I feel as though the best course of action will be to review all of these models. However, this video is pushing a little bit long, so we will definitely get to that in the next one. As always, I want to thank everybody again for watching. The next video is pretty much done. All I gotta do is just get a couple things tightened up here just to make the video not drag on too terribly much. I do kind of like what we ended up with as far as the intake designing goes. However, it's definitely something I'm going to tackle again in the future, as I just kind of threw it together for the purpose of this video, and I did not learn about the scaling issue of what happened in Fusion 360, which you will see in the next video, until well after I already completed everything. But as always, I want to thank everybody again for watching. If you enjoyed the video, please do hit the like button down below. And if you have not already, please do consider subscribing, clicking that bell icon, and clicking all so you get notified whenever we drop new videos. And if you're feeling a little bit charitable, you can head over to support me a little bit more at buymeacoffee.com/FatalRPM. And as always, I want to thank you guys again for watching. This video was actually quite a lot of fun to make, surprisingly. I'm a bit of a nerdy guy, so whenever I can get into the techie aspect of doing things, I generally have quite a bit more fun, which is also probably the reason why I'm the only person on YouTube who doesn't absolutely hate wiring, even though this car has a very special place in hell for its wiring in it from factory. For like the 5th time, I want to thank you again for watching. I do really appreciate every single one of you that watch my videos. Peace out, and I'll see you in the next one.